Good morning, everybody. Welcome to Portage College. My name is Bob Ward. I'm the electrical instructor here for Portage College. I teach third and fourth year, and this morning we're going to show you a little bit of paralleling. We're going to parallel our own alternator with ATCO, and we're going to do that like in the industry. It's a good idea because if we want to turn around and first of all, like say a major hospital or something, big hospital, and they want to save a little bit of money, they can do what they call peak shaving, where they parallel with say the hydro, and they don't get charged as much for the energy that they consume. Okay, so what we're going to do is we're going to look at paralleling this alternator with the ATCO. And we're going to actually be feeding current back into the grid, and we would need a special meter that could turn backwards, but this is a practice that's definitely done in industry. So with that said, this is our prime mover, and in order to parallel with any source, right now we're paralleling with ATCO. Another big important use of this is to have a backup generator set. Say if ATCO should fail, then they could take over the load and carry on. And that would be needed anywhere, like say a runway, say a hospital, any place that's got critical, say a communication site that can't lose power. With that said, right now I'm going to start up my engine, which is a DC motor. I'm going to run my generators up to speed. This here is driving the rotor here, and the output, the EMF, the voltage output is coming out of the alternator. The load, meaning the switches on the outside, dictates the amount of current. So right now we're bringing this up to 1800 RPM. It's a 4-pole alternator. 18 times your 4 over 120 gives us a 60 hertz. Another thing to look at, this is our scope, and what we're going to be looking at is we're going to put, this is us, this is ATCO, and we're going to parallel, meaning close the breaker when we are in the same phase position. Has to be done, otherwise you'll have a short circuit. So a couple of things that have to be done when paralleling: you have to have the same voltage, which we do right down here. This is 112, so we're a little bit less than what ATCO is. So we're going to bump up our voltage, because ATCO doesn't want to change their voltage for us. So we're going to bump it up to about 117. That's controlled by my exciter, which is a DC current going into the field, okay? And that'll produce more flux, and the flux will cut the stator windings and produce an EMF. So we're good with the voltage. To control the frequency is controlled by the speed of the prime mover. And again, right now we're turning at 1800, and we take that, times it by 4, because it's 4 poles, put over 120, that gives us a 60 hertz. Before we parallel, we've got our 3 lights here, and what we want to make sure is we have the same phase sequence. So what I mean is, if we had the wrong sequence, then these look like a disco light. That means the phase rotation is different between us and ATCO, which is wrong. So the only thing we have to do for a 3-phase, it's the same thing with the 3-phase motor. If you wanted to turn it the opposite direction, you just have to change any 2 leads, which we will. We'll change them back. And now we got the same phase rotation, okay? Now, we have the same voltage, same frequency, the same phase rotation, and the 4th thing we need is the phase position. And like I said, we're going to put this over this, and then we're going to close the breaker, and then we'll be paralleled. Okay, so I can tell when we're in the proper position. I'm going to turn the speed up just a bit so we can get us to move. When the lights go out here, that'll be right over top. And as you can see, now I close the breaker, and now we've paralleled with ATCO. And right now, our generator set is hooked up to the grid right now. So if we want to put current into the grid, then we would pick up the speed here. And that would put current back into the grid, and that would give us a bit of a break on our power. The point is, though, this is such a small generator set, so it doesn't really produce that much current. It's more for show. But for fourth year, this is part of their labs, and that's what they'll be doing here. Thank you.